Okay, now we're going to go over compound probability, which is on pages 13, 14, and 15 in your packet. So it says use a tree diagram to find the probability of a compound event. Brianne, Katie, and Dara are lining up for lunch. What is the probability that they will line up in alphabetical order? Okay, so they could line up Brianna, Katie, Dara. Now, this is event 1. If Brianna lines up first, then after her, it could be Katie and Dara. If Katie lines up first, it could be Brianna and Dara. If Dara lines up first, it could be Brianna and Katie. Now, if it's Brianna, Katie, the next choice is Dara. If it's Brianna and Dara, the next choice is Katie. If it's C, B, the next choice is D. If it's C, D, the next choice is B. D, B, the next choice is C. D, C, the next choice is B. So this shows you that there's 1, 2, 3, 4, 5, 6 ways that they could line up. Okay? Now, of the 6 ways they line up, how many of them are in alphabetical order? Well, B, C, D is the only one that's in alphabetical order. So 1 out of 6 ways will give you alphabetical order. So the probability that they line up in order is 1 out of 6. Now, another way you could do this is you could say, okay, they're going to line up, the 3 of them. How many possible choices does the first person have? 3. It could be Brianne, Katie, or Dara. But once one of them lines up for the second position, how many choices are there? Only 2, because there's only 2 left. And for the third spot, there's only 1. So this is another way you can use the fundamental counting principle to figure out there are 6 possible ways they could line up. The other thing you could do for this problem is just actually list them. So I could say I'm going to pretend I'm starting with Brianne. It's either Katie and Dara, or it's Dara and Katie. Let's pretend I'm starting with Katie. It's then B or D, or D and B. And if I start with Dara, it's B or C, and C or B. So you have many options of different ways to do this. You can do the tree diagram, you can just list, and you can list the possible ways. Okay, so now for number 2, you're rolling 2 die. Well, we already went over how many possible outcomes there were when you roll 2 dice. Okay, we know there's 6 possible outcomes for the first, 6 for the second, so a total of 36 possible outcomes. And I have them all listed. Now this question says, what is the probability that the sum of the 2 numbers will equal 5? Well, we know there's 36 possible outcomes, but how many of these will lead to a sum of 5? Now I'm going to circle the ones that lead to a sum of 5. If I get a 1 and a 4, that's 5. If I get a 2 and a 3, that's 5. If I get a 3 and a 2, that's 5. And if I get a 4 and a 1, that's 5. So how many ways can I get a 5? 4. And out of how many total possible outcomes? 36. So what's the probability? 1 in 9. Okay? Now, let's turn the page and we'll look at number 3. It says if you flip a coin 2 times, find the probability of getting 2 heads. Okay? Well, if I flip the coin once, I get either heads or tails. If I flip it again, I get either heads or tails. So my possible outcomes are heads, 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 tails, tails, heads, and tails, tails. Now, what is the probability of getting 2 heads? Well, there's 4 possible outcomes, and how many ways can I get 2 heads? Just 1. So the probability is 1/4. Now, another way to do this probability is to say, well, what's the probability I get heads on my first throw? 1 over 2. What's the probability I get heads on the second throw? 1 out of 2. If I multiply them together, I get 1/4. And that's another way to do it. Now it says, what is the probability that you will get a heads and a tails? Well, I can use the same diagram, but now I'm looking for a different outcome. Well, this has a heads and a tails, and this has a heads and a tails. So there's 2 out of 4 ways, or a probability of 1/2. Okay? Now, the next problem says that I roll a spinner that has 4 equal sections. So I'm going to draw a spinner, A, B, C, D. Here's my spinner. And I roll a 6-sided number cube. And it says, what is the probability of having the spinner land on B and rolling a 4? Okay, well, what is the probability of spinning this and having it land on a B? Well, it's 1 out of 4, because there's 4 possible options. And what is the possibility of rolling a 4 on a number cube? Well, 1 out of 6. So I multiply my 2 probabilities, and it's 1 out of 24. Now, another way you could do this is you could do a tree diagram, but it's going to be a very big tree diagram because you'd end up with 24 possible outcomes. So what we could also do is do a modified tree diagram. I know I can do this to say, okay, to get the spinner, it's 1 out of 4. If I roll a B, I either get 1, 2, 3, 4, 5, or 6. Now, if I have 6 coming out of all 4, that's a total of 24 outcomes. And there's only one way I can get a B and a 4, so it's 1 out of 24. Okay, now, number 5 goes over the difference between when you replace and when you don't replace. So if you're given a bag with 2 red and 3 blue marbles, find the probability of selecting a blue marble first and then a red marble out of the bag if it's replaced and if it's not replaced. Okay? So first we'll do not replaced. So I reach into the bag. I either pull out a red, a blue, or a blue, right? Now, I replace the marble. So if I get the red the first time, I'm still getting red, red, blue, blue, blue. So red, red, blue, blue, blue. I drew too many. And this would be the same for all of these. 1, 2, 3, 4, 5. So red, red, blue, blue, blue. So this is 5, 10, 15, 20, 25 different outcomes. So I know my denominator is 25. And it says, how many ways can I select a blue marble first and then a red marble? Okay? So a blue and then a red, I can do it 2 ways here, which means it'd be 2 ways here and 2 ways here. So it would be a total of 6 out of 25. Okay? Now, another way we could think about that is we're either going to get a red or a blue. What is the probability I would reach into my bag and get a red? Well, it's 2 out of 5. What's the probability I'd reach into my bag and get a blue? It's 3 out of 5. Now, I replace the marble and I reach again. What's the probability of me getting a red? 2 out of 5. A blue? 3 out of 5. If I get a blue first, getting a red would be 2 out of 5. Getting a blue would be 3 out of 5. So to figure out my probability, I would just multiply. So they want to know the probability of getting a blue and then a red. So I do 3/5 times 2/5, which is 6/25, which is what we got doing it the other way. Okay, but now we're going to change it by replacing it. Not replacing it, I'm sorry. So we're not going to replace. So that means the beginning probability is still the same. My probability of getting a red is 2 out of 5. My probability of getting a blue is 3 out of 5. But if I get a red and I don't replace it, my probability of getting another red is only 1 out of 4, because there's only 4 marbles left. Now, my probability of getting a blue would be 3 out of 4, because there's 4 left, but 3 are blue. But if I first choose a blue, 2 out of 4 would be red, and 2 out of 4 would be blue. So to get the probability of selecting a blue then a red, it would have to be blue then red. I would do 3/5 times 2/4, which is 6/20, which is 3/10. Okay? And that's all we're going to do on the video.